My name is, thank you. My name is Gene Jones. I'm with a nonprofit organization called the Southern Waste Information Exchange. In short, 30-second elevator pitch, we basically assist industry and municipalities with waste issues, kind of act as a matchmaker, putting waste generators in touch with waste users to foster recycling. We got involved in the agricultural space back in 1999, trying to figure out why mulch film in the state of Florida is not traditionally recycled. And you'll hear more about that in the course of the presentations that you'll see in the next day and a half. If you allow me, let me make a couple of opening comments. Take care of the admin. Try this again. Yep. Go for it. Thank you, Tim. Now I got to put my glasses on. That's what happens when you've been in the industry for 44 years. You start losing your eyesight, your hair turns gray. First off, everything that you see over the course in the next day and a half, all the presentations, we're going to shoot the PDF. I'll provide those post-event in the proceedings out to everybody. We are recording this via Zoom. Welcome our virtual attendees. Let's see here. Bathrooms are across the hall in the main hotel registration area. All the breaks are going to be in the exhibit hall next door. Lunch will be outside. So there's a lunch ticket in the back of your badge. We're going to have everybody walk outside and around to turn in your lunch ticket so we can kind of keep track of how many lunches are being used at this point. Let's see here. Any problems, come see me or our staff, my son Colin and my daughter-in-law Hannah, and we'll take care of you. Lastly, I need to kind of thank the sponsors, because events like this wouldn't be possible if it weren't for our sponsors. So I encourage everybody to take advantage of the exhibit hall next door. You know, the advantage to these type of conferences is the value of it is the networking that takes place, and so I strongly encourage everybody to do that, meet and greet, and learn as much as you can. Lastly, I've got one thing I need to show everybody. We had one of our speakers last year, Katie Malarkey, who was with Rochester Institute, is doing a research paper on the use of agricultural plastics in the United States, and she finally got through. It took her about a year to do this project. So if you want to, you can take a screenshot or a copy of that. It was scanned directly to her article. I also put it up on the Ag Plastics Conference website, so if you need to download it. I think that's pretty much it in terms of opening comments. I'm going to get us going right off the bat. Oh, if everybody will turn their phones on vibrate for me. I'm going to kick us off into the opening panel. The session is going to be moderated this morning by Sam Sugerman, who's a sustainability manager at Toro Ag. And I'm going to let him introduce the panelists. The way the program will work is I've kind of asked the speakers to kind of do like a 15 to 20 minute talk and leave time for Q&A. We are, like I said, doing this by Zoom. Everybody in the back, I will get you seats in just a minute, hang on. Bear with us. I'm going to have somebody in here walk around with a microphone so we can capture the questions as well as the answers that are being recorded. So with that, Sam, I'm going to turn it over to you, sir.
Awesome. Just real quick, folks in the back, there's a bunch of seats up front, and if you guys want to stand, that's cool. If you guys want to take a second to locate, we'll take a second to locate. As everyone's getting seated, I just want to first off thank Gene. I can't say enough good things about Gene, the things that he's done with the APRC show and within kind of the whole ag plastic recycling world. It is a small and interconnected world, and I think a lot of those bilateral connections between folks in this room are really thanks to Gene's kind of leadership in kind of connecting everyone and having forums like this where everyone can engage. Ag plastics are only growing. They're unique in their kind of benefits to agricultural systems, and the recycling and need for recycling is only growing with it. So big thanks to Gene. Just one round of applause for Gene for putting together this show. I actually think Gene left the room. With that, I want to hand it over to Ted Kaiser, the president of Doc 7 Materials Group, and he'll give a presentation on the markets for ag plastics. And this is a really topical conversation, especially with some of the geopolitical things that are happening in the news, if you guys haven't seen them.
Thank you, Sam, and thank you, Eugene, and everybody with his team for putting together the conference this week. And so we'll talk a little bit about some of the markets. I want to preface this by saying this is my second attempt at using AI to actually make these PowerPoint slides. And so it did a pretty good job. I'm giving it some bullet points and things that I want to say and have it in slide by slide, and it generates the images, but it's not perfect. So if you see some spelling mistakes in there, just know that that's not me, and the guy giving you this information is still a little smarter than the AI, and I think everyone in this room is also still a little smarter than the AI, but the day is coming where it's going to be more powerful than us probably. So we'll talk a little bit about some of the agricultural plastic markets. First, we'll talk a little bit about the export side and kind of give an overview of which materials are moving right now and why. And then we'll talk a little bit about some of the regulations, especially on the export end of the equation, some of the logistical challenges for exporting these agricultural plastics materials, and what can we do to make these materials more marketable, whether that's for export and for domestic as we look to the future, and what role export still plays in a future where maybe we're doing more on the domestic side. So ag film quality tiers and what's moving, right? We typically have, you can kind of put things in three categories. You have high-end materials like a cotton wrap, a greenhouse film, drip tape, drip hose, things that are not too dirty. So typically you're talking about material that's probably 70% yield or higher, or at least close to that. Typically those can move to mechanical recyclers a little bit more easily. Then you have a lot of materials in the middle, such as banana film, almond film, silage films. Those would kind of typically be materials that from a mechanical recycler standpoint might yield 50 to 70% range. And then you have a lot of low quality materials, such as mulch film and strawberry film and tunnel film, and these are typically low yielding materials. And so historically speaking, it was always the high quality materials that would move first and easiest. And then a lot of the middle grade materials. And your low grade materials would either move not at all or very, very little. And right now, particularly on the export side, is a little bit of a weird time. And it's partly due to overall market dynamics with how kind of pricing is with virgin plastic. But the high quality material, still moving. Maybe at lower prices than we typically see historically, but you can still move a lot of these materials for export. The low quality, surprisingly, we're able to move some of those low quality materials right now. Price is very, very low. Most of it is actually subsidized by the grower or some other entity, the farmer paying for offtake or whoever may be willing to do so. But some of that is actually moving. And a lot of the stuff in the middle is not moving so well because it can't be subsidized by the grower or isn't willingly being subsidized by the grower. And so it's kind of fallen into this category where a lot of that material is being hard to move right now. Now, why is the low-end material moving? It's just because of pricing, because it's so cheap, and even though it's very low yield, there's some companies out there that are willing to process that material because it's good volume, it's consistent volume and consistent kind of material, and even though the yield's really low, it's just working out in the economics of the supply chain right now to be able to move some of that. Now, that doesn't work across the board. That only works from certain areas. It works from California. It does not work from Michigan or Virginia. So On the export side in particular, we'll talk about first. What are we facing right now in moving some of these materials? Probably the biggest issue right now is regulation. There's a number of countries overseas where these materials typically move, and that's primarily Southeast Asia, Malaysia, Vietnam, Thailand, Indonesia, Taiwan. There's some other countries that take material too, sometimes other parts of India, the Middle East, occasionally Europe, South America for certain types of ag plastics, but the bulk go to Southeast Asia markets. And each of those countries in Southeast Asia are facing some sort of regulation as it relates to the import of plastic scrap materials. And so in particular, Malaysia is one of the biggest ones, and they are currently in the process of redoing their entire import process for scrap plastic materials. And so there's a lot of uncertainty there regarding these regulations. The stated goal is that in Malaysia in particular, the countries that are part of the Basel Convention are the ones that will still be allowed to export material to Malaysia. And those shipments will face an inspection upon arrival when they get to Malaysia. Now, sounds not too bad. Problem is, the U.S. is not part of the Basel Convention. So, at the moment, the U.S. is technically left out from shipping scrap plastic to Malaysia. Now, that's supposed to start potentially on October 1st. No one really knows for sure if that's going to start. They've been pushing to somehow have a resolution for U.S. plastic, but that hasn't come yet. Nothing is definite. You also have some people over there in Malaysia, as in the case in many of these Southeast Asia countries, that are able to import this material regardless of the regulation. So there's a lot of uncertainty. Everything's kind of a case-by-case basis, and it's definitely causing problems for both the movement of certain types of ag plastic and the pricing. Because if everyone's uncertain about it, they're going to want less for the risk of shipping it over there or trying to import that material. So there's more custom scrutiny going on, so that just means we have to watch the quality really well. We've got to put good bales in the container. We can't be just shipping the worst stuff. We need to make sure that even the mulch film, even though it's dirty, that it's rolled up nice and looks good and doesn't have a whole lot of excess dirt, and it's not soaking wet. So we have to take some of those precautions. And this is really just having a domino effect. And it's going to be really interesting to see what happens, because in 2026, Europe is also supposed to ban the export of scrap plastic from the entire EU. So now, take Malaysia, for example. If U.S. isn't part of the Basel Convention and they're not allowed to import plastic scrap from the U.S., and then Europe bans it, where are they going to get their material from? It's going to be a real problem for some of those recyclers there to survive if they're not able to get material from both the U.S. and Europe. There's just not enough material out there from other sources. Then, of course, we have the always prevalent logistics issues. And that, Kevin, years ago, I was up here talking about logistics being the main issue with agricultural plastics. How do you get it from the farm to where it needs to be recycled? And he remembers that every year and reminds me of that. But that's the first take is, how do you get it from the farm, from the source to where it actually needs to be recycled? That's the first challenge. Now, once you actually get to where you can try to solve that, you still have a lot of issues going on in the overall logistics market. There's still effects going on from back to COVID. Nothing has really ever normalized in shipping since then. It's kind of been one cascading problem after another, and just when you thought, okay, things were starting to turn the corner, it was getting a little bit easier to export and ship material around the world, the Red Sea is basically closed due to the terrorists targeting shipping, transiting that area. So with that being said, all the ships have to go around the Horn of Africa. It increases the cost, it increases the transit time, and causing a whole bunch of congestion in various places, especially in Southeast Asia. The ports are extremely congested there. It's difficult to get space, to get bookings, to get material there in a timely and cost-effective manner. And all that trickles down to affect What can we do with ag plastic? Can we ship it out? Can we pay to somebody for the material, to collect it, to process it, to bale it, to roll it? All those things are hurt by these factors. So we kind of talk about what I call the big four, right? You have rates. You want to have a good rate. You want to be able to get space. You want to be able to get it there fast and have a good transit time. And then at destination, we have what's called free time for any of you, that do some shipping. You know about this. When it is sent to another country, you have a certain number of days to clear that cargo from the port without them charging you for it. And because of all these congestion issues, a lot of the shipping lines are trying to cut back that free time. So you have to try to get it out of the port faster. Most people can't do that because it's congestion. If you're shipping 10, 15 containers of mulch film into a customer and they're trying to get it all out of the port in the same week, they need time to be able to do that. So they're trying to cut back that time. So of these big four, ideally you want to be able to have all four things go well. You want to have a good rate, you want to be able to get space, you want to be able to get it there fast, and then you want to have good free time when it arrives. You'll be lucky if you get two of those four things in a shipment right now. You want good free time at destination, well, you got to pay a higher rate for that. You want to be able to get space, maybe I got to pay $100 more to get space this week to get this cargo out. So you have a lot of issues there, and that trickles down and affects what we can move, when we can move it, and what we can pay for materials. Is there anything we can do to improve the materials for these markets? And this will kind of lead into some of the domestic discussion too. First, the good thing about ag plastic is typically it's one polymer. You don't have mixed materials. You might have some materials that have additives and some other minor challenges, but for the most part, ag plastic is good from the standpoint that you have all one type of plastic and you don't have to do a lot of sorting. You just have to deal with the dirt and moisture. Downsizing and downgauging of some of the materials, that's typically something that's unhelpful for mechanical recycling in particular. We always try to discourage when we hear some discussions from manufacturers about, oh, well, we're going to make the film thinner. And typically for mechanical recycling, that's not great. Also not great necessarily for retrieval. From a materials marketing standpoint, we love when the material's been removed with mechanized equipment from the field. It's cleaner, it's roll tighter, it's neater for shipping. Those are all good things. And so to the extent that we can continue doing that in some of these processes, that helps to create markets for the material. And finally, the next question is, can we pre-process this material? Can we get any of this dirt out before we send it somewhere? Historically, for export, that hasn't worked great because even pre-processing, just to get out some of the dirt, isn't enough, right? Because it still has to be washed. So they're still running their wash, whether it means their yield's going to be 50% or 30%. There's not been enough incremental value there to justify it on the export side. On a potential domestic or advanced recycling side, that might be a different story. And this is where we'll talk a little bit about some of the domestic options that we see coming up in the future. So just what do we see for the future of exports, first of all? Everything is very day by day, week by week. A lot of regulation changes, a lot of logistics changes. How do we deal with the volatility in that and kind of see where that goes? Overall, low virgin pricing, does that ease up? And can we get some relief there to get the market to come back a little bit for recycled demand? And does domestic or advanced recycling take away from export? In the long run, it certainly might, but I think both can kind of work hand in hand potentially because different locations are better for export. Different locations are probably better for domestic. And certain materials probably will still have some export homes, even if we do a lot of domestic recycling down the road. So on the domestic side, what do we see or what do we need as feedstock providers of agricultural plastics? There's a lot of question, right, of what kind of material can be sent to a domestic advanced recycler when they get going. And so really what we're trying to determine is where can we go with it? Can we take agricultural plastics and kind of send it as is directly to an advanced recycler, and then they can process it and make new products from it? Or do we have to do some sort of pre-process? Do we have to shred the material? Do we have to wash it? Does it have to be pelletized? Does it have to be densified into aglo? And who is doing that? Is it somewhere closer to the farm side? Is it some sort of pre-process hub? Is that pre-process hub run by someone like us who's a feedstock provider, or is it run by the advanced recycling company? Or is it run by another third party? And so who will do that process if they won't take these materials as is? These are questions that are not really answered yet that we're starting to look for answers on. And there's potential there to have regional hubs for these materials and collect material and either just collect and feed into these systems, or collect, pre-process at a hub, and then feed that material to an advanced recycler. So there's a lot of questions there, but on the bright side, there's a lot of projects. There's at least 40 plus projects, and this might even be an old number from that I had seen, because projects every day are kind of coming and going right now. But there's a lot of investment there. Billions of dollars are being invested in some of these advanced recycling plants. So we're hopeful that there'll be some opportunities there for agricultural plastic. As far as we know, where are we right now with some of the domestic or advanced recycling? Is any being accepted right now? We don't really see anyone that's taking in much in the way of bales of agricultural plastic, bales or rolls in its raw form. There's probably some out there taking some on trial basis, but we're not seeing a lot of sustained baled material of agricultural plastic going. We have heard some instances of pelletized agricultural film going to some of these advanced recyclers that have started. And so that's something to look for to see where that goes and if that continues to emerge as a market. Now, dirty ag film, because it is inconsistent, what we need direction from the domestic and advanced recyclers. Well, what is accepted? What form do they need it in, and what is the dynamics of that, right? Do you need that material in its raw form, and where? And at what cost do we have to be able to get it to you? So this is really a big question from our standpoint as a feedstock provider, because we don't know what do we need to standardize. We want to standardize the product that we can provide to you, but we need direction from that industry to say, hey, we can take it as is, or we need it to be cleaned up slightly to get it to, let's say, 50% yield instead of 30% yield for mulch film. So there's a lot of questions for this as we talk about the path forward. Can we get some of those standardizations in place, and can we do some trial projects, some pilot projects, and see where that goes down the road? So that's pretty much it. I kind of wanted to leave the domestic advanced side a little open. I know there's going to be some people talking about that this week, and get some better idea of where that goes going forward. But wanted to give you guys a little bit of overview of what we're seeing, especially on the export side, as we have options for agricultural plastics. Thank you.
Thank you, Ted. And just as a reminder, we're going to save some time at the end to ask the panel questions with the remaining time. I just want to kind of highlight what Ted was talking about. There's needs for domestic markets. As we're seeing a lot of the geopolitical uncertainty, we're seeing the need for people to start consuming this material to give kind of a headway to advancing kind of some of the nascent recycling world within the US. So there's companies that are really leading the cutting edge and kind of finding a symbiosis between the end of life of these ag plastics and putting it back into their new products. And with that, I want to introduce Mark Trenchard with Charter Next Generation, who's going to be presenting on Beyond the Field and rethinking some of the ag films for a circular future and really identifying some of these opportunities for symbiosis between the recycled material and end products.
Thank you, Sam, and good morning, everyone. Thank you very much for being here today. It's great to see a lot of people interested in the space attending a conference like this, and thank you to Eugene for putting this on year after year. I think it really is beneficial to all of us in the industry. There we go, we got it back on. Sorry, guys. Today I want to share a story, and it's not just about recycling agricultural plastic. It's a story about reimagining the role that film manufacturers have in this ecosystem. And it's every one of you, too, that have attended here today. We can have a truly spectacular role in building a circular economy. And now this is not a product pitch, and I'm not here to hand out trade secrets either. I'm here to pull back the curtain and just share a little bit about what C&G is doing. Because while we may all compete in this market together, we share a bigger responsibility. We're all here to find a solution to this problem. And it's a bigger problem than that we face. And we all have to work together to make it work. Now, we're all working with different pieces of the puzzle. The problem is, sometimes we try to complete the whole circle all in once. But when we focus on building individual nodes, specific solvable pieces, that's when we see the gaps that need to be worked on, but we can also celebrate the progress that we have made. So let me start by giving a brief introduction to Charter Next Generation. C&G is one of North America's leading film manufacturers. We operate across food, healthcare, industrial, agriculture, and more. But here's what matters most. No matter what market we're in, we show up in the same way. We push past the status quo. We use equipment, our resins, and most importantly, our people, to drive meaningful change. We ask the questions that challenge convention, and then we build the answers. Now, our sustainability platform stands on 3 pillars. Number 1 is recyclable formats, even where infrastructure is still catching up. Number 2 is post-consumer recycled materials, and we scale those for reliability. And number 3 is compostable and bio-based films, where applications make sense. In agriculture, we lean on every tool that we've got. We've got deep R&D in film tech, a willingness to step outside our lane, strong partnerships with recyclers, equipment makers, and end markets. Now let's be honest, the agricultural plastic waste problem is huge, and it's not yet solved. We're early in the adoption curve, and companies still have to protect their IP and their profitability. And that's the reality of capitalism, and I get that because I'm part of that too. But here's the thing. We normalized space travel. We created the internet. And are we really saying that solving the agricultural plastic waste problem is too hard? I don't really buy that. And the solution is to break the problem into smaller parts. Now think back to 1903 when the Wright brothers took their first flight, 120 feet in 12 seconds. And today we fly across continents in pressurized metal tubes while streaming movies. We just need to start and keep building. So here's what that looked for us at C&G. From 2020 to 2021-22, C&G commercialized an ag film. And it was one that checked all the boxes on performance at the farm and enabled a circular model allowing for mechanical lifting and recyclability with high-quality polymers and resins. From 22 to 23, we developed pilot collection programs, and we tested post-use film for recyclability, and we faced the infrastructure realities head-on. 23 to 25, we are focused on enablement of collections and real-life next life outlets for PCR materials. But true circularity doesn't start at the end of life. it starts at the very beginning with the design. And I want to share a personal story. 10 years ago, my brother Rob and I set out to develop the world's best plastic mulch film. And that meant turning 40 years of industry thinking upside down, throwing out the old rules, and coming up with something totally new and different. And that's when Solar Shrink was born. Now, Solar Shrink is a plastic mulch film that uses 30 to 50% less plastic. It's thinner than anything else in the market. But at the same time, Solar Shrink is 300 to 500% stronger in tensile properties. Let that sink in. Solar Shrink is also the only film that shrinks tightly to the bed when exposed to sunlight. No more flapping, no more billowing, and no more damage to crops. Solar Shrink is easier to lay, easier to retrieve, manually or mechanically. Solar Shrink is ultra smooth. It's easy to clean and made with advanced high quality resins for top grade PCR. And yes, it's still the most cost effective solution for growers. If circularity is an archway, then film manufacturers are the keystone. Without designing for circularity from the outset, the whole structure risks collapse. So when we piloted the retrieval of used Solar Shrink, we learned a lot, and we learned very fast. Step one was to get the film into the market. But then came the resistance, questions about retrieval methods, skepticism about scaling. And the truth is, large-scale retrieval and processing infrastructure is still very underdeveloped. Mechanical recycling works, but it has its limits. Pyrolysis has promise, but it's tied to volume, geography, and cost. But what we did learn was that the quality of the PCR will be inferior to standard streams of PCR, and we need to accept that for now. So I want to pause here and ask an important question. Where does a manufacturer's responsibility truly begin and end? And Sam touched on this in his presentation as well. Do manufacturers just buy film, buy the resin, convert it into a film, send it out to a farm, and let someone else deal with it? Should recyclers be the ones designing better films for optimized recycling? And why shouldn't a mechanical lifting equipment manufacturer invest in a local recycling facility near where their equipment is sold? Now, these are all just rhetorical questions, but they do matter. This matrix on the screen shows a simplified version of agriculture's circular ecosystem. On the left are the core responsibilities of a film manufacturer. That's where our lane has traditionally been. As you move across, you get into the peripheral areas, places where we've historically said, that's someone else's job. And then there are the minimal responsibility zones, which many film manufacturers see as beyond their scope. But here's the truth. Real transformation happens when someone, whether it's a manufacturer, a recycler, or a brand, steps beyond their comfort zone. That's when real progress accelerates. That's where breakthroughs happen, and that's exactly what I want to share over the next few slides. So here's a perfect example, slip sheets. Now, slip sheets were not part of CNG's core business. We're a film manufacturer. We don't supply warehouse logistics products. But the opportunity was right in front of us. We realized that with the right blend of PCR, including PCR from Solar Shrink, we could create durable, reusable slip sheets that replaced traditional kraft paperboard. Now, there's a major brewery in North Carolina that has adopted them. And instead of being a single-use disposable item, these slip sheets cycle through their supply chain again and again. That's less waste, less cost over time, and a brand new high-value outlet for agricultural film PCR that might otherwise struggle to find a home. It's not glamorous, but it's effective. And it's proof that thinking outside your core lane can open big doors. Another example is floor protection for construction sites. This came from our building and construction team. They developed a high-mill, non-slipped product that bonds easily with standard seam tape. It's made with over 90% recycled content, and it's tough enough to be reused across multiple jobs. Think about the volumes of film this can absorb. Every roll of this product is diverting material from landfill, giving PCR a second life in a completely different industry. And it's not a down cycle. It's a high performance and high demand product. Again, this isn't something you traditionally connect to agriculture, but that's the point. The more markets we can feed recycled film into, the healthier the circular economy becomes. Now let's talk scale. Retail is a powerful outlet for PCR. We've partnered with major retailers to supply products like high-strength garbage can liners, made with a significant amount of recycled content, including ag film PCR. It's not just trash bags, it's also painter's tarps, masking films, light-duty floor protection. Now these products move in very high volume and they get PCR back into the hands of consumers in ways that make sense for the market. Sometimes the key to scaling circularity is not chasing the sexiest product. It's finding the big volume, steady demand outlets that can absorb material day in and day out. And finally, let's bring it back to agriculture. C&G recently developed a 1.5 mil high repro cast film with over 90% recycled content into it. A lot of it came from solar shrink mulch film as well. It's heavier, yes, it's durable, and early field trials are showing real promise. This is where the loop starts to close, when material from a grower's fields can be retrieved, recycled, and can come right back into agriculture in a form that meets performance demands. That's circularity in action, not just as a concept, but as a tangible reality. Our advantage is that we operate across multiple agriculture, packaging, and construction sectors, meaning that we can connect the dots that others can't. We can create markets for recycled content. We leverage our buying power to offset the costs and use distribution to break logistical bottlenecks. Now, agriculture sits at the crossroads of two of the world's biggest challenges. The first is plastic waste, and the second is food security. If we can solve it here in one of the most scrutinized categories of plastic, we'll set a precedent the world can follow. And if you're in this room, then you have leverage over one of these two levers. So circularity is not just an idea, it's a movement, and it's in motion. My ask is simple. Leverage your partnerships, stay creative with potential use cases, stay flexible in piloting and scaling, and above all, take ownership of the pieces that you can control. We don't need to solve the entire circle at once. And remember the story that I shared earlier about the Wright brothers and their first flight, 120 feet in 12 seconds. That was the starting point for an entire industry that now takes us across oceans in hours. Right now, the agricultural plastics is our Kitty Hawk moment. We're just lifting off. The flight is short, the journey is long, but it is possible. And like aviation, the progress will come faster than we think if we just keep building, testing, and collaborating. We don't need to solve the whole circle at once, but together we can absolutely build it, node by node, piece by piece. Thank you.
Awesome. Thank you for that, Mark. And yeah, I mean, they don't have the exact numbers on how much ag plastic is used, but there's numbers based on kind of proxies from acres in the US, and there's estimates that there's about 1 billion pounds of agricultural plastics used on an annual basis. Don't quote me on that. I see too many people writing that down. But when you have 1 billion pounds and you have a lot of outlets for that material within products, you have to start getting creative in the solutions on where these materials go. And one of those creative outlets for these materials is agricultural plastic mulch and asphalt pavements. So I want to hand it over to Dr. Yufeng Zhu, a postdoc researcher at the Department of Civil Engineering at California State University, Chico.
So, good morning, everyone. My name is Yufeng Zhu. I'm a postdoc researcher at California State University, Chico. It's really an honor to be here. So last year in July, I came to the United States from China. So it has been more than 1 year. I think my English has improved a lot. But I still need like Google Translate to my backup plan. So yeah, so today I will do my best to deliver my speech clearly and effectively. I hope my talk will easy to follow. So thank you so much for your patience and support. Thank you. So let's get started. So today my topic is utilizing recycled agricultural plastic mulch in asphalt pavements. The outline of the presentation. So I will start with background recycling of solid waste in asphalt pavements. So in asphalt industry, we have a really long history of responsible and successful recycling of solid waste. So today I have two examples. So one is chrome rubber. So we have more than 60 years. And also we have plastic. It has more than 30 years. And then I will talk about some challenges and opportunities in agriculture, in agricultural plastic recycling. And then followed by the USDA project. So this project is one of the tasks under the USDA project. So as I mentioned, asphalt industry has a long history of responsible and successful recycling of various solid waste. For example, the chrome tire rubber, the steel slags, the reclaimed asphalt pavement, we call it RAP, and recycled asphalt shingles, we call it RAS. And also the waste carbon fibers and also plastic. So for the plastic is the main purpose of this presentation. So firstly, I want to talk about the history of recycling chrome rubber in asphalt, which has a long and very successful application in asphalt industry, especially in California. So we believe this experience gained from the rubber can provide very valuable insights and guidance for the using plastic in asphalt. So the rubber used in asphalt started from 1960s and 70s, especially in the very low risk application in road. For example, the pothole patching or the pavement preservation, like the chip sealing. And then in 1980s, the pavement design starting using the rubber, and then so the rubber starting used in the structural layer of pavement, and then back to 1990s, some politics, standards, and the specifications of rubber use in asphalt, and then in 2000. So some, the economic analysis starting in rubber in asphalt, and then back to 2010s, the recycling of asphalt rubber mix. More and more studies started on this topic. So if you look at the figure here, so in 2006, the Caltrans start the asphalt rubber usage guide. So they have a guide to promote more and more rubber use in asphalt. If you see the right line here is a goal of rubber use in asphalt pavement. So from 2006, the goal is 20% of rubber use in asphalt. Now the goal is 35% of rubber use in asphalt. So if you look at the real data, the below line, so now it's more than 35% of rubber use in asphalt. So now let's look at the recycling of plastic in asphalt. It has more than 30 years. It's also had early development of recycled plastic in asphalt, both for lab and field testing. For the lab testing, it has some very successful application, but also some had issues. So for the researchers, they back to the lab to figure out which way is a better way to use plastic into the asphalt pavements. So generally, we have two methods to incorporate the plastic in asphalt pavement. One is called wet mixing method, which is blend plastic with hot asphalt first. So the plastic is as a asphalt modifier, and then we add the modified asphalt into the aggregate. And one is called dry mixing method. So we blend plastic with aggregate first, and then we add the unmodified asphalt. So in our project or in our task, we evaluate both methods to incorporate the plastic into asphalt. And in 2018, China had a policy that stopped the import of waste plastic from other countries. So more and more researchers and DOTs began to explore the use of plastic into asphalt pavements. Well, looking forward, learning from the rubber experience, so we need more like specifications, legislations, and also standards. So how can we have like better quality insurance or quality control for using plastic in asphalt pavement? So when talking about agricultural plastic recycling, there are different types of plastics. So different type of plastics, they have different melting points. For example, for LDPE, the melting point is between 110 to 130 degrees Celsius. And also the melting point is one of the very critical very critical property for plastic that will affect the compatibility with asphalt. And still, right now, the recycling rate is still very low. It's less than 10%. So I think it's because the very high contamination level of the mulch waste. And the recycling methods, including the mechanical method, chemical method, and the biological method. And in the worldwide, the amount of the agricultural plastic is around 12.5 million tons. So that's a very huge number. And if you look at plastic mulch here, in US each year, there are 450,000 tons in US. And and if you look at here, the plastic mulch is made from LDPE. So the melting point is between 110 to 130. It's lower than the asphalt production temperature. So the asphalt production temperature is around 130 to 180. So which is very good news. So the mulch, can be melted into the asphalt or modified asphalt during the asphalt production. But for the downside, the mulch waste has very high contamination level. It's around 30% to 80% by weight. But maybe the asphalt can have higher tolerance to accommodate this very high contamination level. So with this background, this task has three objectives. So the first objective is we want to assess PE mulch waste and its contaminants on asphalt modification. And the second one is we want to evaluate the recycling strategies, for example, the dry mixing method versus wet mixing methods on the performance of asphalt mixtures with PE mulch waste. And then we produce plant production asphalt mixture with processed mulch pellets. So if you are not very familiar with asphalt pavement or asphalt, here I have like 2 slides to briefly talk about asphalt pavement. So if you drive on road, more than 90% of times you drive on asphalt pavement. And for asphalt mixture or asphalt pavement, there are 2 components. One is called aggregate or rock. So it's around 95% by weight. And then the second component is asphalt binder. So roughly speaking, is 5% by weight. And for extend or enhance the performance of asphalt mixture, we have some performance enhancers. For example, polymers such as SBS polymer or SBR polymer. And so maybe the plastic can be one of the polymer to enhance performance of asphalt mixture. And then we have also we have fibers and anti-stripping agents or some additives such as warm mix additives, antioxidant actives. And in asphalt pavement, there are 2 main distresses. The first one we call rotting or performance deformation. So this rotting distress is high temperature induced distress. So during the summertime, the asphalt is very soft. So in that time, the rotting happens. And the other one we call it cracking, is low temperature induced distress. So comes to the next section. So how we select the appropriate asphalt binder in different climate zones. For example, in Alabama or Texas, the temperature is very high, right? So we want to, or we prefer to use stiffer binder to reduce rotting. And for cold area, for example, Alaska or Minnesota, we want to use soft binder to mitigate the cracking. And by right now, we select the binder or select the asphalt based on the performance grade, or it called PG. So PG 64 minus 10 is the binder used in Chico in my workplace. So the PG stands for the performance grade, and the 64 means so this binder can perform well up to the maximum pavement temperature to 64 degrees Celsius. And minus 10 means this binder can perform well in the minimum pavement temperature of minus 10. So here is the map of California. So you can see different areas have different appropriate asphalt. So for example, in coast area, we can use PG 64, and in the Central Valley also PG 64, but in the hot area, we need to use PG 70. And comes to the objective 1, so we use PG 64 as the working binder. So we use new PE mulch and recycled PE mulch to modify binder. We use different dosage of new PE mulch. Firstly, we use different new PE mulch to modify the binder. For example, 0.5%, 1%, 3%, 5%, 10%, and 15% by weight of binder. And the optimum dosage were the 3%, the 5%. And we use the same dosage of recycled PE mulch, 3% and 5% to modify the asphalt. And the results show that if you see here, if you see this table, if we use new PE mulch to modify the binder, it can extend the bender used in California. For example, the house area. So it's reached PG 70s. And similarly, we use recycled PE mulch to modified asphalt. It also can extend the asphalt use in California. For example, the house area. And also because of the climate change, some researcher, for example, Raymond from UC Davis, so he recommend to use PG 70s instead of the PG 64 asphalt because of the temperature increase. And here is the conclusion: the PE mulch can increase the high PG, so increase the high temperature performance, and then benefits rotting resistance. So to study the influence of contamination and bender modification, we compared the new PE mulch versus recycled PE mulch. The recycled PE mulch have lower modification than the new PE mulch because of the the recycled PE mulch has higher contamination. And then to further validate the influence of contamination, we also collect recycled PE mulch from Washington, Nebraska, Florida, and California. And all they have different effective PE contents. And we use recycled PE mulch to modify asphalt. It can be seen a very linear relationship between the high PG or the rotting resistance with the effective PE content. So now moving to the performance evaluation of asphalt mixture, which corresponds to the objective 2. So we conduct a series of experiments using PE mulch waste collected from strawberry fields in Washington and in Nebraska. And we compare the PE mulch modified asphalts with 2 control mixture. So one control mix with 25% RAP. So the RAP is the recycled asphalt pavement. And another control mix is without any RAP or any and any plastic. So we evaluate both the recycling method. So one is wet mix method and the other one is dry mix method. So for the wet mix method, so we modified bender first with the plastic, and then we add the modified asphalt into the aggregate. Dry mix method, we blend the plastic or the plastic mulch with aggregate first and add the very hot unmodified asphalt. And we perform very comprehensive tests. For example, the cracking test, or rotting resistance test, and moisture damage resistance test. So if you look at the fracture cracking resistance, it's called ADOCT test. So the dry mixing method perform well than or perform better than wet mixing method, and the ranking is from the highest to lowest is the control mix without wrap or without plastic, and then the dry mixes, and then the wet mixes, and the last is 25% mix. So the dry mixing method is a preferred way to include PE mulch waste. And then it also allows a higher dosage of PE mulch waste. But this is just for the for the cracking resistance. And then we run another cracking resistance test. It's called semicircular bending test. It's also the concurrent is pretty the same with ADOCT test. So you may be wondering, so during the when you use the dry mixing method, so how much plastic blending into the asphalt. So we use some results from the cracking test. So we estimate the partial blending ratio between plastic mulch with hot asphalt blender. So the results show that it's between 47% to 56%. So roughly speaking, 50% of plastic melt into asphalt. And then we did the 4-point beam test to figure out the stiffness of the mixture. So let's say the ranking. So 25% wrap mix had very high stiffness, and the control mix has the lowest stiffness, and the plastic modified asphalt mixture in the middle. And then we do the fatigue cracking resistance test. So we did the fatigue cracking resistance. So we did cracking test at different strain level, at for example 200, 300, and 400 macro strain level. So it shows 3% recycled P mulch using the dry mixing method has more balanced fatigue resistance performance. And then we ran the rotting test. So all mixes has very good rotting resistance. With the rot depth is lower than 12.5 millimeter at 25,000 wheel passes. And the ranking still, the rot mix ranking the first, and then the 3% recycled P mulch ranking the second place. And also we ran the tensile strength ratio test. It's called for the moisture damage. So very interesting. The addition of recycled PE mulch or new PE mulch has no improvement or degradation on moisture resistance. And also we scale up to produce the plant asphalt mixture for 3 mixtures. So one is control mixture without plastic, and one is mixed with Washington mulch. So the effective PE content is 68%, and one is from Florida, Swiss, and the mulch effective PE content is 20%. So now we just ran the anti-cracking test. It shows the mixture with the plastic have better anti-cracking property. It's better for the cracking property is better than the control mix. So next we will run like the rotting test, fatigue test, and moisture damage test. So now it's a big question. So how much PE waste can be recycled into rows? So let's break down into simple math. So if you use 3% by weight of binder, either using dry mixing method or wet mixing method, so you can use 3 pounds recycled PE in 1 ton asphalt mixture. And for example, in California, annual consumption of asphalt mixture, hot asphalt mixture, is around 20 to 25 million tons. So if all the asphalt mixture use recycled PE mulch, you can use 60 million pounds in all asphalt mixture just in California. So we assume 20% of asphalt mixture will use recycled PE mulch. So it's about 6,000 tons just in California. So roughly speaking, 30% to 45% mulch will use annually in California. And finally, let's see the summary here. So The addition of recycled PE mulch increases the stiffness or benefits the rotting resistance, but slightly compromises the cracking resistance. And also the effective plastic content is a dominating factor will affect the degree of bender modification. And the third one is dry mixing method is recommended to incorporate recycled PE mulch into asphalt mixture. And the partial blending rate during the dry mix method is around 50%. So I want to thank all the collaborators, and also this work is supported by the USDA project and to improve the end-of-life measurement of plastic mulch in strawberry systems. If you're interested in this work, please see the website here, and also contact Kun Zhang, PhD, associate professor from Chico State, is my supervisor. Thank you so much.
Awesome. Thank you for that, Yufeng. I don't know about y'all. I grew up in Michigan, so seeing those physically distressed roads with all the cracking stuff on there, it's maybe a little Freudian of me, but all I saw was my Honda Odyssey pulled over in AAA coming. So let me just summarize this. You guys have all heard the 3 R's, correct? Reduce, reuse, recycle. Raise your hand if you knew that that was a hierarchy. That your first step is to reduce, then you reuse, and then you recycle. Ag plastics, we don't really have the fortune of being able to reduce. Ag plastics are functional, and they, to Mark's point, they add for food security. You take away mulch film, and you just increase the fertilizer use. The mulch film does a really great job at suppressing weeds. You can't really reuse it. I don't know how many of y'all interface with farmers or growers too much, but there's a lot of health and safety concerns of having these ag plastics on your field collected and then reused, and honestly just the labor costs and so forth of collecting this material and then putting it back out, it's more than kind of just buying new product over and over. So we don't have the luxury of reducing and reusing. So we're left with recycling, the third on the hierarchy. And when you have to recycle, you're burdened by the reverse channel. The reverse channel is everything after the consumer touches the material. Who buys from Amazon? I imagine pretty much everyone here. I just bought a new volleyball from Amazon yesterday. But Amazon, within their reverse channel, they can't really handle the products once they're being returned. There's stores popping up that are pretty much like Goodwills where you can dig in piles and try and find these rejected Amazon products. I know a guy in Salt Lake City that just got submitted an RFQ to get about 3 truckloads a day of the Amazon returns that he's going to try and separate and funnel down kind of material value chains to recover some of the materials for it. But there's large companies that are absolutely burdened by the reverse channel, and they don't have a solution for it. What Ag Plastics is doing is we're tackling the reverse channel. We are tackling the reverse channel to make sure and facilitate the recycling process, because it sucks to see someone burning their ag plastics, and that still happens in Florida. And it stinks to see ag plastics going to a landfill, because this is, I know that Hoop House and Greenhouse film is white, but I still like calling it all black gold, because the mulch film and the drip tape, it's black gold. It's functional value that you're just throwing away. Landfills take up a finite amount of space. The cost of landfilling products is increasing every day. So it sucks to see it incinerated. It sucks to see it landfilled, because it's black gold and you don't want to see that go away. So we tackle the reverse channel. And with the reverse channel, it starts with the consumer. That consumer is the grower, the farmer. And I don't know how many of y'all are hikers or climbers or anything with the mountains, but whenever you're up in the mountains, you always see these false peaks. You think you're getting to the top, your legs are starting to give way from some of the pain and soreness, but you get to the top and then there's another peak and another peak and another peak. And there's all these false peaks and there's all these problems that we have to deal with on the reverse channel of the ag plastics. So to kind of summarize what all these speakers kind of put together is, you're first stuck with the collection and the logistics problem. All of these farmers, they're using upwards of 20,000 to a couple million pounds of ag plastics a year. You need to consolidate all of that material to a place that it can get on a truckload at about 40,000 pounds. Or else you're really just transporting air, and it sucks from all the business perspectives here to transport air. And beyond that, you're already dealing with things like mulch film and drip tape. Their yields, their plastic yields can be 60 to 70, sometimes 50%. So you're not only transporting the plastic, but you're transporting the dirt. So that first step, you need to engage with the growers that are collecting this material at the end of life, and then they want to go on vacation or grow their next crop. They don't want to deal with the plastic, and you have to convince them to consolidate and, consolidate that material. And there's folks like Andros and Flipping Iron here that have really worked on kind of fixing that problem. And we're getting a lot of good headway. And then you have the logistics problem that Ted kind of brought up, that you need to be by a port if you're going to be exporting it, or you need to be by a recycler if you're going to domestically report it. It costs, I just looked at the freight quotes yesterday, to send something from California to Texas, it costs about $4,000 on a truckload. That's about 8 to 9 cents per pound on the logistics. When you're buying recycled plastic for 30 to 35 cents, that, 20 to 25% cost is really, to a degree, insurmountable. So you have these logistics concerns. And that's just the first phase. Then the material arrives at either the port or it gets to the domestic recycler, and it's dirty plastic. It needs to be cleaned so it can go into a chemical recycler, or it needs to be cleaned so it can go into a mechanical recycler. And when you have these dirts and you have kind of, I don't want to say antiquated, but you don't have the high-tech kind of mechanical washing that can reduce all the dirt contaminants from it. And even like at Toro, when we're producing drip tape, it's a thin product. We get burdened if we have more than like 0.3 or 0.4% dirt and like ash contaminants on it. So you need to get this product really clean to make sure that people like Mark can put it back into physical products. So there's hurdles at every single step in the reverse channel, and it's unique and honestly really great that the ag plastic industry is tackling that reverse channel instead of doing what other industries are doing and trying to hand off that problem to other people. So the people in this room that are bilaterally collaborating with each other and working at kind of surmounting these hurdles, that's what the industry needs to make sure that we can move from a problem to a solution. So we have Mark using the end products, and we have Yufeng getting really creative and finding outlets for these materials. We have a plastic use that's not going away, because as I mentioned, we can't reduce and reuse. So we find ways to recycle. We find creative ways to recycle. And we're here together, and this room keeps getting bigger and more familiar because there's more people that are tasked and have decided to look at the I'm so bad at adages, but take the bull by the horns and tackle this solution head on. So I just want to appreciate the speakers, and I want to appreciate all of you for being here and tackling these reverse channel logistics issues within the ag plastic recycling. With that, I want to start handing this over to kind of questions, and I know that there's questions in the audience, but I just want to prompt one question just to kind of get the conversation started for everyone on the panel. There's problems, there's false peaks, and there's opportunities. Each of you is tackling the reverse channel from a different perspective and from a different glance. Where do you guys need help? And I'll just open that up to whoever wants to go first.
Is this working? Here we go. We got it. Yeah, that's a really good question, Sam. Where do we need help? And like my speech said, I feel that in the agricultural plastic space, especially relating to films, the film manufacturers are the keystone. And like I said, we need to develop a film that can be, suitable for recycling, to give back a very good quality film. But I think what we need is the infrastructure to recycle. And it's great to see some of the other, people out there with display booths in the recycling industry. coming to us with solutions and saying, hey, we can clean this material, we can recycle this material. But what it needs investment from the industry. And it needs all of us to work together to do this. It's not just going to be one company to pull it together. And there's some really good partnerships going on at the moment. I know, the guys at Flipping Iron are doing some great stuff with Andros, and that's a fantastic partnership. And I applaud you guys, I really do. But it needs more than that. It needs everyone to come together to pull it, to make it work. And that's why we're here. Yeah, that's why we're here.
And not to quote Theron or Dan or anything like that, but I think they would take those words directly out of your mouth and say they need more domestic outlets and more infrastructure to recycle this material.
Hmm.
You think that?
Yeah, that's what I was going to say, is I think we have some export outlets, but we need more, right? It's one thing, okay, we can do some material from California, but that doesn't solve the ag plastic problem in other locations. And what we really need is, I feel like, not only domestic options, but the support from those domestic recyclers potentially to say, okay, as I alluded to before, this is the form that we need it in. This is how we can use it. If you give it to us in this quality, we can take it and we can process it. But at the same time, it's not just the form, it also has to be, kind of as Mark alluded to, there has to be financial support there too. It can't just be, oh, okay, well, we want it in this form and we'll take it for free. Well, if you need it in that form, we have to do something to it. We have to collect it. We have to pre-process it or do whatever we need to do to get it. There has to be some financial support in there and some economic value to the materials too. So how is that created in order for us to be able to, provide these materials to an outlet? So we need direction and we need support to be able to do that. And then we could start to put together that infrastructure to say, okay, this is how we can get it to where it needs to go once we know what they can kind of pay for it and what form they need it in.
So in asphalt industry, so maybe we need more collaborators or some investment to scale up for the field section for using the plastic or the plastic mulch waste. So maybe we want to, like the railroad, we use some more and more like plastic in the road. So that's that's my question.
Great, thank you. And I know it's been about an hour and 20 minutes that you guys have let the coffee kind of settle in. I know that the energy's kind of coming up, so I'm going to open it up to y'all for questions, and raise your hand, and Gene will run around and give you the mic.
All right, question here.
Hi, thank you. This one's for Ted. Ted, it's Steve Y with the County of San Diego. What do you see from your perspective the role of both local government and then state government?
I think local and state government can play a really big part in this. Other countries, Canada, Europe, for example, and I know you'll probably hear a little bit about this later today or tomorrow. They have different EPR programs and other resources available that cover some of these costs of collecting these agricultural plastic materials. We don't have anything here in the U.S., particularly on a national level. And there's not a whole lot on a state and local level that's out there, but there would be definitely room for support for that because the benefits to a municipality or to a county or a state is, okay, we're diverting these materials from landfill. We're saving landfill space. Can that hold some value to be able to, provide some incentives, or even if it's not a financial incentive, even if it's just simply direction, saying, a local government saying, hey, we know, there's growers here that have a bunch of this type of material. Can you come and get it? Can we work out something to figure out how to set up a collection program? That's an important piece of it as well, especially as we look at places that collection is not already happening. If we move to some of this domestic markets, there's going to be collection going on in places that haven't been export friendly. and it's going to be like starting from scratch. You know, a lot of these places are just either burning the plastic or landfilling it or leaving it on the farm. So it'll be building an entire infrastructure from scratch in certain locations, and there'll be a lot of room for whether that's local government, state government, even farm bureaus, you know, other farming organizations that might be able to help in those areas too.
Just to add on to that really quickly, there's not really great delineations of recycling across state boundaries. So you have ag plastics in pretty much every state in the US, but you don't have homogeny in the kind of delineations of recycling, and that really kind of affects how corporations are going to involve and invest themselves into recycling. And I'm kind of agnostic if you want to consider chemical or mechanical, both in the same kind of vein in recycling, but there just needs to be more homogeny across state lines. Also, there needs to be kind of feasibility studies on EPR laws, extended producer responsibility laws, especially looking at kind of the different policy mechanisms that like European countries and like the Waste Directive are taking about, to understand kind of what fits kind of the socio-cultural behaviors of growers and farmers in the US, instead of just taking something in Europe, installing it in the US, and seeing behavioral concerns on the implementation. Darren?
Hang on there.
This is for Dr. Zhu. I actually going to talk about what you're doing in my presentation tomorrow, but I was curious, given that that asphalt blends are regulated somewhat by government agencies, what regulatory or technical like challenges do you foresee trying to bring ag film into asphalt? I know it's accepted with tires, but I'm sure that wasn't just, you know, hey, we put tires in there now. There's got to be public roads are pretty regulated. So what do you see any challenges there?
I think maybe the the mulch film is is a chemical thing. I think for the real challenges is some chemical thing. But it's not in my field. I'm a civil engineering, so I think it's high contamination or some micro plastic problem or pollution may happen. So so that's my yeah.
Hang on one second.
Oh.
Is it approved by these agencies to, we know we could put tires in there, but can mulch film be put in there as not just like, yes, it's successful, but do the agencies allow for that to be put into the asphalt for public roads?
But right now, actually, I don't know. But right now, I can do some, research, or I will Google it. So now, I don't think we have any legislation or specification to use plastic. So maybe in the future. So,
Darren, I can answer that from the state of Florida's perspective, and the answer is no, right? You got to go through DOT, and it's an elaborate process. So that's where I think the value of the research that Doc is doing on this issue is to open up the discussion. Can we use this in state-based roads? Ishmael.
Pretty much on the performance enhancer for the asphalt, have you thought about modifying the plastic with nanomaterials to actually increase the performance in it while you're blending it into the asphalt? Meaning a little bit if you can actually add some graphene into it through the plastic. When you're master batching the plastic, you can add some graphene so you can enhance the properties of the asphalt. Oh
yeah, we use some the pyrolysis wax, or we use different wax when pyrolyze the plastic, right? So we use wax. We use different kind of wax from FDPE or HDPE. So not that good. Yeah, not that good. So we are trying to use different, the method to collaborate the plastic right now.
And what about you on the plastic film? Have you actually tried to use these nanomaterials in the plastic film as well? To see if they can actually reduced a little bit, or?
No, we haven't really put graphene or anything like that in the films. I think that'll come though. As you know, advancements in film technology happen, I do believe that will happen.
Thank you.
Jasmine?
I just wanted to follow up on Theron's question, and we're working collaboratively with Chico State University, and it depends, Theron, on what road you're talking about. So for example, in the project that we're proposing, where it's a private land at Regen, and there it's allowed. So it really depends on the boundary. If you're working on a county level, you would need county approval. And then if you're looking for state application, then yes, you would need the DOT. But right now, the use of plastic recycled into asphalt is very commonly used. And so it might not necessarily be that you have to get specific approval for mulch, but that you would have to show that this technology is still meeting the same qualifications and requirements that other ag plastics are doing it. So they don't necessarily base it on a specific plastic type, but rather on whether it meets the qualifications of road requirements that DOT has.
Ron, you can conclude us with the last question. We
Yeah,
have
thank
a
you
couple
for that.
minutes.
Yeah, thanks for that. No, I would just say that I agree with that because you have DOT, but you also have parking lots. You have massive companies that don't need to get the approval. They try to comply to DOT, but they don't need the approvals, and that's the easier way to go. DOT is really tough. You look at asphalt shingles, they've been trying for years to do that, and they're building plastic road in my town in Texas. And it's very, it's really welcome and people are applauding it, but it's like 2 or 3 miles, but it's still something. It's a beginning. And I would say I agree. I would start with the private sector and then let it filter over to the DOTs and then you have the man from San Diego here. Do you talk to the DOT? I mean, my question is, do you talk to your DOT? And I think there's a lack of coordination among state agencies too. Because here again, San Diego's here. They should say to their DOT, hey, look, this is a great idea. How can we get it started? That's my thought. So.
Yeah, I'll just add on that there's also kind of like other externalities within some of these asphalt constructions, and kind of just not speak on behalf of San Diego, but I know that my small town where I grew up in Michigan, there's been like a greater emphasis on permeable parking lots to capture rainwater and things like that. So there's a lot of things to consider with the rollout of kind of polymers in the asphalt and things like that. So it's a complicated question, and it's exciting to see the conversations being driven up the ladder. Awesome. Once again, thank you to everyone on the panel. Thank you to Gene.
Before we break, I want to do something real quick. I'm going to put my waste matchmaking hat on real quick here. If you're in the room and you have plastic, you're a generator or you're a broker looking to get rid of it, raise your hand. Okay, everybody take a look. All right, put your hands down. If you want plastic, raise your hand. All right, so look around. All right, if you're a service provider, raise your hand. Okay? That's what I want to do. You guys need to talk. Let's go into the networking sessions.